So we have seen how to factorize a quadratic polynomial and what are the different examples of quadratic polynomial, and we have seen how to factorize, find the factors of quadratic polynomial. Okay, these are the factors of a quadratic polynomial. Now if you want to go further in this concept, okay, x square plus 5x plus 6, the zeros were minus 3 minus 2. Okay, now if you want to find from the same equation x square plus 5x plus 6, I'll take here, okay, x square plus 5x plus 6 is equals to 0. Okay, if you want to find the sum of the zeros, we found the zeros. Okay, what are the zeros we found just now? Our zeros are minus 3 minus 2. Okay, so what is the sum of the zeros? Sum of the zeros means add them, minus 3 minus 2, what do you get? Minus 5. Yeah, and if find the product of zeros, minus 3 into minus 2, what do you get? Minus into minus plus, 3 2 times is 6. This is from the zeros. Okay, but if I want to find the sum and product of zeros directly, so for that you have a formula in polynomials. Okay, alpha plus beta is equals to minus b by a. Okay, and what is alpha into beta? Product of the zeros, it is c by a. Yeah, few students had a doubt, so I thought of explaining this. Most of the students are already perfect in it. It will be a revision for you. Okay, so minus b by a and c by a, this is sum of the roots and this is product of the roots, the second one. Okay, even these formulas are also important. What is the formula? How do you find sum of the roots for a quadratic polynomial? It is minus b by a. Product of the roots is c by a. Remember these two formulae. Now we need to find the values of a, b, c here. So what is a? A is coefficient of x square. So a is 1 here. B is coefficient of x. What is b? Coefficient of x, that is 5, and c is 6, the constant term. Okay, now I'll substitute these values and let's see what will be our sum of the roots. Minus b, what is b here, students? B is minus 5. B is 5. Okay, so minus b means, what should I write here? Minus 5 by a is 1, so minus 5 by 1 is minus 5. You can see we got the sum of zeros, yeah, by the formula and by the roots, sum is same. Then product of the zeros, c by a, c is 6 by 1, 6 by 1 is 6, so we got the product also. Okay, so this is the way we can find sum and product directly by using the formulas alpha plus beta and alpha into beta, minus b by a and c by a. Okay, so every equation we cannot find the zeros in this way. Okay, especially for 10th class I am telling this, we cannot find the zeros of the polynomials directly by splitting middle term. Every equation cannot be splitted. Okay, so you can use this method for finding sum and product. Like let's take one more example. If you have a polynomial, say x square plus 2x plus 1. Okay, x square plus 2x plus 3. Okay, I'll take 3 here. So can you solve it by splitting? Can you find zeros of this? 3x square, 3 ones are 3. Okay, 3 minus 1 is 2, but 3 into minus 1, if I take 3 minus 1 also, 3 minus 1 is 2, but 3 into minus 1 is minus 3. Do you have minus 3 here? So we cannot find. Every time we cannot split the middle term and find the roots. Okay, so what we should do, we can find the sum and product directly by using the formula alpha plus beta. What was alpha plus beta? It was minus b by a, and alpha into beta was c by a. Okay, So what is ABC here? Here in this, A is 1, B is 2, and C is 3. Just substitute minus B by A is minus 2 by 1, minus 2, and C by A is 3 by 1, that is 3. So this is the way we can find sum of the zeros and product of the zeros. Okay, so what is our sum of the zeros in this? Minus 2, and product of the zeros is 3. Now imagine if sum and product of the zeros are given to you. Okay, that is minus 2 and 3. These are the sum of the zeros. Yes, suppose if sum of the zeros is given, sum is given as minus 2 and product of zeros is given as 3. This same question I am taking. Okay, minus 2, here minus 2 and 3. So usually sum is alpha plus beta. We take sum as alpha plus beta. This is the value of alpha plus beta, and product we take as alpha into beta. So if you want to find the equation back from the sum and product of roots, if sum and product of roots is given, if you want to find the equation, so the formula for that is, what is the formula for that? X square minus sum of the roots into x plus product of the roots, isn't it? This is the formula in second exercise of polynomials. Okay, I already taught you, but again, as few students had a doubt, okay, I am recalling it for your revision. So now we'll substitute. Okay, whenever you have to find the equation from sum and product, if sum and product is given and you want to find equations, so substitute that sum and product in the formula. So x square, what is sum of the zeros? Alpha plus beta. This is alpha plus beta. Okay, so sum of the zeros is minus 2x and product of the zeros is 3. Okay, so x square minus into minus becomes plus 2x plus 3. Okay, so let's check our equation now. X square plus 2x plus 3. What was our equation here? X square plus 2x plus 3. So we got the same equation by using this formula. So this is also one of the most important concept. Okay, same thing you can do for all this, every quadratic polynomial. Okay, for every quadratic polynomial you can do this 3 steps. What are the 3 steps? First we can find the zeros, then second we can find the sum of the zeros and product of the zeros. Okay, and the third we can find equation. Okay, equation from sum and product. We can find equation from sum and product. So these 3 are very important methods of polynomials. Next, going to linear equations concept. Pair of linear equations, in that you have to practice the concept of conditions. A1 by A2 is not equal to B1 by B2. Okay, for this condition in the pair of linear equations, a1x plus b1y plus c1, 2 equations are given. Okay, I even sent a video on this, so you have to be thorough in the concept of conditions. Okay, if a1 by a2 is not equal to b1 by b2, okay, then the condition is it has unique solution. How will be the solution? This type of conditions have unique solution. Okay, and when you draw the graph, the lines are intersecting lines. You will get intersecting lines. Okay, when you draw the graph of those 2 equations, and they are said to be consistent. What do we call them? Consistent. 3 things you have to remember whenever this condition exists. Okay, it has a unique solution, they have intersecting lines. Okay, when you draw the graph, the lines are intersecting and this type of equations are consistent. Okay, so you can take different examples, okay, from exercises and work on that. Then the second method was second condition was a1 by a2 is equal to b1 by b2. Okay, so suppose a1 by a2 is equal to b1 by 2, like you found a1 by a2, you got 1 by 2, you found b1 by b2, you got 1 by 2, then go for c1 by c2. Okay, so and you found that c1 by c2 is 3 by 2, suppose, so is not equal to c1 by c2. From where do we get these values? These values we get from equations. Okay, so if this condition exists, then you can say that what you can say in this, the lines are parallel. How will be the lines in this case? The lines will be parallel. Okay, the graph of this type of equations will have parallel lines, and the solution is in no solution. What do we say for this? No solution, because the lines are not meeting anywhere. So this type of condition exists. If this condition exists, then you can say it has no solution, means you cannot find solution only, no solution, and they are said to be inconsistent. Okay, inconsistent. So I am recalling this because few students had a doubt in this also. Next, third condition. What is the third condition? First condition we have got a1 by a2 is not equal to b1 by b2, and it had unique solution. And the second one we got a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. Okay, and it had no solution, lines were parallel, and it was called inconsistent. Now what could be the third condition? The third condition is a1 by a2 is equal to b1 by b2, b1 by b2 is equal to c1 by c2. All will be equal, means you found a1 by a2, you got 1 by 2, even b1 by b2 is 1 by 2, and last c1 by c2 is also 1 by 2. So in this cases we say that they have infinite solutions. Okay, infinite solutions. Why infinite solutions? Already I sent a video on that. Okay, infinite solutions. So both equations are nothing but the same, infinite solutions, and the lines are coincident. What do you mean by coincident lines? Coincident lines. Okay, the lines will be same lines. Okay, one above the other. Okay, so the lines are coincident. Coincident lines, and this type of condition is consistent and dependent. Okay, this is consistent and dependent. So only which one is inconsistent? The second one. Okay, if the second condition comes, it is inconsistent. This is consistent and dependent. So these are the three conditions which can be asked in MCQs from pair of linear equations, and any other concept can also be asked. Okay, using the same conditions you have many questions. Okay, in the exercises. So if you have any doubts, further any doubts, you can get back to me so that I can